Ladies and gentlemen, calculus students and people of all ages, we're going to integrate x squared divided by the square root of 1 minus x squared. And don't be shy of this integral. We know we have to do a trig substitution, or at least we should try it, because we have a square root with two terms that are squares. And that's it. Like this top term, don't even worry about it. It's not the derivative of the denominator. So we're going to do a trig substitution, and I'm going to walk you through it. I'm going to hold your hand step by step. This is my method. I think it's one of the fastest methods that you can do. And what I do with these is I take the square root thing and I call it something. I always call it g, but you can call it whatever you want. And I set it there. And then the trick here is to rearrange this equation such that it looks like the equation for a right triangle. A squared plus b squared equals c squared. So in this case, the 1 is in the hypotenuse if we draw the triangle, and you can have the x or the g on either side. It really doesn't matter. I'm just picking the x on this side. Sometimes I put it on the other side. Now, in these trig substitutions, we want to write theta in terms of x. So this is where I put theta in the right triangle. And in terms of x, we'll use cosine because that's the adjacent over the hypotenuse. So cos theta equals x. And then we also want to write g in terms of x because g is our square root thing right here. So we'll use sine because sine is the opposite over the hypotenuse. So now that we have our conversions between theta and x and then theta and g, we're going to set up our substitution. We just need to know what dx is. So this cos theta equal x equation, we'll take the derivative and then rearrange such that dx equals negative sine theta dx, d theta, because negative sine theta is the derivative of cos theta. Now, we can substitute all of this stuff in, and this gives us cos theta squared because cos theta is x, and then dx is this negative sine theta d theta. You see that? And then the square root of 1 minus x squared, that's our g. And check this out. In all its glory, we can cancel out our sign and hopefully things are better. That's the whole point of these trig substitutions. Now, we have a cos squared, which kind of sucks. It would be nice if it wasn't squared. But fortunately, we have a trig identity to get rid of the square. And we're going to use that one. This cos 2 theta equals 2 cos squared minus 1. If we solve this equation for cos squared, we'll get cos 2 theta plus 1 all divided by 2. We kind of transpose this 1 to the other side. So that's cos 2 theta plus 1, and then we divide everything by 2. So this is the cos squared theta here. And the negative is because of this negative here, it's still along for the ride. Now, I'm just going to yank out the constant, the negative 1/2 here. And at this point, we can integrate each term separately. And that's our friend. The integral of cos theta is sine theta. And that's what we're doing right here. It's sine theta, except we have a 2 theta. And so if we want to do the derivative of this, it'd be cos 2 theta times the derivative of the inside function, which is 2 because there's the chain rule. And we don't have a 2 here. So we need to have a 1/2 when we do the antiderivative. Hope that makes sense. Now the integral of 1 is our friend. That's just theta. And we're basically done. We just need to substitute back in terms of x. And x is equal to cos theta. So theta equals arc cos x, right? And now we need to know what sine 2 theta is. We know what sine theta is, but not sine 2 theta. However, we can invoke another famous trig identity. Sine 2 theta equals 2 sine theta cos theta. And if we do this, we know what sine theta is. That's just g right here. We know what cos theta is. That's just x. So our sine 2 theta divided by 2 is g times x. So we'll substitute all those in. This is our negative 1/2 coming along for the ride. Our gx is our sine 2 theta divided by 2. And then our arc cos x is our theta here, plus our friend, the integration constant. And we're basically done. We'll just put everything in terms of x. So instead of writing g, we'll say what g is. It's the square root of 1 minus x squared. Here's our x squared. And this is our integral in all its glory. Another one bites the dust. I've got tons and tons and tons, like way too many integrals that I should have. I just do this. I guess I love doing integrals. So if you want to learn more integrals, check out them all, binge watch the integrals, and best of luck in your course. Cheers.